Before planets existed, before Earth even had a name, the universe was wild, chaotic, full of mysteries waiting to uncovered. Some stories start with the Big Bang, but this one starts with a close call.
Imagine a massive star speeding through space, passing so dangerously close to young sun that gravity twisted and stretched them like cosmic tides. As in, muntik na sila mabanggaan. Another cosmic crash.
What happened next? Legit, it could explain the birth of every planet, including Earth. Parang cosmic spaghetti, the sun will stretch and pull into a long strand of hot gas.
From chaos came collision, and that near collision event sparked one of the most explosive ideas in astronomy, the tidal theory.
That cosmic moment may be why we exist today.
The tidal theory was introduced by James Jean and Harold Jeffreys in the early 1900s. Their idea, a giant star passed extremely close to a young sun. The star's gravity produced streams of hot gas from the sun, like molten lava, being stretched into space.
Those streams of hot gas cooled, condensed, and formed tiny solid chunks called planetesimals.
Over millions of years, these collided, combined, and grew into planets, the worlds we know today, Mercury to Neptune.
According to the tidal theory, the early sun existed alone, a hot, gaseous mass. At some point, a second star or a passing star or intruding star passed very close to the sun. The close approach caused extremely strong gravitational or tidal forces on the sun's outer layers. These tidal forces pulled out a long, extended filament, sometimes described as a cigar-shaped stream, of solar gas and plasma from the sun. That filament of material then detached or was drawn away from the sun and went into orbit around it. Over time, this gaseous filament cooled, condensed, and fragmented, eventually clumping together to form the planets. In other words, under the scenario, the planets were born from solar material that was literally pulled out by the gravity of a passing star, rather than forming a protoplanetary dust and gas disk.
The tidal theory was one of the earliest scientific attempts to explain how our solar system formed, using gravity and basic snap methodology.
It opened doors for more accurate models later on, like the nebular theory we use today.
Eventually, scientists discovered problems with the theory.
First, the sun's gases wouldn't cool fast enough to form planets.
Second, stars passing that close is astronomically rare, like 1 in a trillion.
So the tidal theory was rejected, but its impact on astronomy remains huge.
Even if tidal theory wasn't perfect, it helps us shape our understanding of the solar system.
It taught scientists to ask questions, challenge ideas, and keep searching for the truth.
And every theory, even the wrong ones, bring us closer to real answers.
That's the beauty of science. It evolves and so do we.